Great. And as people join, they'll just join and we just continue. And the recording will be available later today again on YouTube. Okay. So last week we basically ended around study unit 4-5. And there was just one or two things that from last week that I added that I just want to nearly cover again for you, and then we continue into the next study units of a discrete Poisson binomial, and hopefully we start with the normal distribution as well today. So let me just, I added, where was the question? In here. So I just wanted to add something that when they give it with a decimal, and then they nearly ask you to plot the stem and leaf. So I think what the important thing is here with this one is nearly to take the hint that they're talking about. So they tell us that round up the 18.5 and the 30.5. So if I don't say that, we take it as is, but because they're telling us that we round that up to 19, we round that up to 31. Okay, and then we need to look at the stem and leaf. So remember, stem and leaf, again, we need to sort your data first, so from smallest to biggest. So 19 is your smallest number, then it is 20, then it is 22, 25, and 51. Okay, so let's look at smallest is 19, so that is your stem, that is your leaf, stem, leaf, so it is 19 is the first, 20, 22, 25, 31. Okay, so option 1 is actually the correct one. Let's just look at why the others are wrong. Okay, so 19, so this one wasn't sorted. That is why that one is wrong. This one, it should have had 1 and not 10. So when we look at it, we look only at the pure 1 because that represents the tenner, the 10, and the 20 and the 30. So this one is also wrong. Okay, so this one, it wasn't rounded up. That's why that one is wrong. And with this one, okay, this one is just totally confusing because where you have a 19, a 20, then you suddenly have a 2 and the 5 and the 31. So that one is also wrong. Okay, so I just wanted to show you on the stem and leaf, if I do give you an added decimal, what do you do? If it wasn't rounded off, then one of the options would have been, then it would have been something like 8.5. But again, we don't really see that ever in a stem and leaf, so they would tell you to round it off. But if it wasn't rounded off, it would have looked something like this. But again, they would not, they would probably ask you to round it off. Okay, so that was just an extra one of stem and leaf that I wanted to show you. So hopefully that nearly covers all the possible stem and leaf questions that they can ask. So let's just continue to the next set of questions, which will be some extra questions on the discrete. So what I also wanted to include from last time that we didn't get to was the discrete, where we do a mean and the variance calculation. Okay, so for this I created a spreadsheet as well, and again I will show you that. Okay, so when we work out the mean, and that is maybe just, let me first do that. So when we need to work out the expected value of the mean of a discrete, the formula for that is that we need to basically every time say the x value times the probability. So the x value times the probability. So the x times the probability, and we need to do that for all of them. And when we have that individual ones, we need to say the sum of them. So that is how we need to work out the expected value. So I thought, again, it might be just a bit simpler to work it out in Excel, and nearly want to show you while I'm doing it, so that you also, when you need to do it, you can also use my template. But I was also very happy that you just follow, and I will share this later on as well. Okay, so if we work out the expected value of x, that is basically, like I showed, it's that times that, which for this one is 0. That times that gives you the 0.2. That times that will give you 0.4. That times that will give you 0.9. That times that will give you the 0.6. The 5 times the 0.05 will give you 0.25. When you add all of them, you're supposed to get 2.35. So let me just, so that is what your expected value will be. And if we go back to 2.35, there is the option of 2.35. Okay, so again, a bit simpler to do it in Excel. No problem for the expected value if you did the calculation on your calculator as well, and just every time set, this is how you're going to multiply it out. Also, really no problem with that, because I do think for the expected value, that is also still relative easy to do that. So we basically, for the expected value, can do that. And obviously, the next question that I want is to show is a follow-up on this data that then shows that you need to work out the variance. Okay, so hopefully in the exam, if it's a follow-up question, that they tell you now that the expected value of x was 2.35, so that you don't need to work it out again. So I will just check in with the lecturer to find out about that. That we just make sure that whenever there's a follow-up question, that the information that you need is carried over. Otherwise, you need to nearly do it all over again. If you did it like this, and hopefully the data didn't change. So let's just make sure again on the data it's 0.1, 0.22. So when I look at that, just want to make sure 0.1, 0.2, 0.2, 0.3, 0.15, 0.05. Okay, so at least the data is the same. So to work out the variance is a bit more difficult. So to work out the variance, it is a few extra steps. So we need to say the x, which is 0, minus the mean that you calculated, we're going to square that, and then we're going to multiply it by the probability. Then we need to do it for all of them. So it is another 5 extra calculations, and those answers we will then need to add up to get your variance. So again, it is nearly a lot of work to be done, and hopefully again Excel will just make it a bit simpler for us. So when we need to work out the variance, remember the formula was your x minus your mean. So I'm just going to add that to the power of 2, and then we still need to multiply that by the probability. And so I will just add all of that into the Excel. It's basically the 0 minus the mean. Let's just anchor that one to the power of 2. And let's just make sure that the formula, that it reads it correctly, times that probability. Okay, and then it will calculate it for that one, for that one, for that. I just want to make sure that all the formulas are correct in this instance. Correct. So the variance of x is the sum of those ones. Okay, and let's see if there was an option of or 1,8275, or maybe we need to round it off. Okay, so let's see, it's rounded off to 2 decimals. So let's just do that. Okay, 1,83, 1,83, 1,83. Okay. So let me also just, while we are here, if you need to add more, let's just see that. Okay, so that is just if you need to add more variables for in the exam. It will also calculate that for you. Okay, so basically that is the formulas and the way that we do, or the easier way to do the expected value and the variance for the discrete probability. Okay, so before we go into the next set of probabilities, any questions up until this point?
No.
Cool. Okay, so let's go into the next set of questions. So let me just move that along. Okay, so when we start with the next, we need every time to, if they don't tell us, we need to first find out for ourselves, is it a binomial distribution or is it a Poisson distribution? Okay, so the difference in the two is nearly that binomial gives you an option between two, so nearly a yes, no option, or a failure or success, something like that. And then the Poisson will always have a time associated with the question. So it will normally be something in minutes or hours or days, weeks. So just, yes.
Is it possible you could read the question instead of just sorting it out? Because when you're sorting it out and then I'm trying to read the question and you're talking and then I don't understand the
Cool.
question. So,
Perfect. No worry
Thanks.
at all. So I will get to how we read it and to pick up some things as well.
Thank you so much.
Perfect. No, that is definitely what I will do now. So don't worry. Okay, so let's first look at it, and then we decide if it is binomial or Poisson. So the South African Embassy in Sydney knows that voter turnout rate is 91%. So that already tells me that a turnout rate is nearly you come to vote or you don't come to vote. So that already tells me we're looking at things that are two. So a yes or a no. But let's read further just to see if there's anything else. So in a random sample of 20, so there they give me a bit more information. What is the probability that at most 13 voters would turn out? Hint, the 20 voters in independent trials. So that already also tells me it's binomial. Can either turn out or not turn out. Okay, so that is nearly the link to that, and they tell us also in this one it's two outcomes. So, and there is no time associated with this, so this is a binomial distribution. Okay, so if we then work with a binomial distribution, we need to look at what we need for binomial distribution. So we have the n is 20. We need to have the x value, so at most, so we'll now need to also remember what at most is. So I'll copy that table in that we did last time as well to get the at most. And then we have the percentage that turn out is your pi. Okay, so with this one, the nearly giveaway was and they won't always tell you there's two outcomes. So this one was a nice add-on. They don't need to always tell you that. This one was a nice add-on. They don't need to always tell you that it is independent trials. Okay, so those were the hints in it to tell us that it is a binomial distribution. I just want to go back to the table, this one, just to, because I thought this was a nice one to add, that we know what the at most and things like that means. So when they talk at most, let's get that, where was it? Words at most, it means less or equal. So we will need to work out the probability that x is less or equal to 13. Okay. So here's an interesting one, because firstly they give you let's not mark it like that, because then we think that is the correct one. So firstly they give us actually the binomial formula. So that is nearly to make sure that we know the formula, but the formula is in the pack that the lecturer will share later as well. It is in your study guide. So then they give you 4 other probabilities that hopefully one of them is then maybe the correct or the incorrect one. Also very interesting is, so yeah, that there's nothing that I can read in this yet, but when you look at these two, the one is nearly 9987, the other one is when you set 1 minus the 0.9987. So 4 and 5 actually adds up to 1. So when I look at this question, I'm like wondering, this is weird. So maybe there's a hint in here that it's one of those two that are the number that we are looking for. But let's go and find out. So I have the table here as well, but now what I've seen is, so we need to go to 20, 13, and 91. So, and unfortunately this one now is, when it's printed, obviously it's better to work with, because now suddenly we need to work with this one where it is, and let's see, I don't think I can write anything else on this. So it's N20. Remember, I just want to see if I can write here something. No, not my signature. Okay, so it basically just wants to add something. Okay, so that's not gonna work for me. Okay, no, that's not gonna work for me. So let's just skip that. Okay, so I need to look for where pi where that one is equal to 0.91. So if we go across, we see on the table it only goes to 0.5. So now we look at it, okay, not finding anything there. Now we need to go back. Okay, So now we see there is your 0.91. Okay, so there's for 0.91. But now, how we read this table is we need to start at the bottom and read it. Okay, so normally if it was 0.01, I would have said 0.01, 20, and I would read it from this way all the way to this. Now we need to say from the 0.91 x, and that's why a printout will work much better. X0 is that, so x13 is there, and if we need what they said less than, we basically, now I just want to see if I can make that longer, and we need to have all of those x's. Okay, so I just want to go across. I just want to check if that is 13 again. Okay, so now it's, see, so that's why working with this on the PC is also very difficult. Okay, so those numbers are 0,0011, 0,0002, 0,0000. Okay, so that nearly, I want to move that over, but we can just, okay, so it would have been, and let's make it, it would have been all of these that I would have added, but the rest is just zeros in any case. So for this one, I would have added 0,0011 and 0,0002, which would have given me 0,0013, and hopefully there is an answer, yes. Okay, see, so the problem with this one is, and the difficulty is, if we have done it the other way around, if we kept that 0,91 there and we've worked down to 13, actually it would not have given us that, which is cool. So the only mistake we could have made then is if we said the more than. So if we did the other way around, and then we would have gotten the opposite, the 0,9987. So if we used it as that way around, we would have gotten the other number. So again, I think we have now copied this in and use it. I thought this was very nice to have this table in, because it nearly, this is all the ways that they can ask it for you. And it nearly continues up until study unit 9, 10 nearly. So I will also, as we go along, I will take this table with and copy it in every question that we need to have it in. Okay. So this was the binomial, and this was a nearly a difficult one. And what I've seen is they like to give you where the n is 20, so that you nearly need to work with this type. And they normally also like to give you anything above 50, so that you nearly need to work with the bottom part, and nearly need to know that when you work with the bottom part, we need to work with these x's on this side. So yeah, it is one of the more difficult ones with a binomial distribution is when we do it like this. But I have a few more, so let's just look at a few others as well. The other thing that they like to do, and so here they've basically asked one question on need to work it out. So they've asked us when n and x they give us, and we need to work it out. They can also in a question ask you to look at different points or probabilities in that one table. So let's look at the info that they give us and then what they ask us. So first, let's see if it is binomial or if it is, I just want to see to make it a bit bigger as well, if it is binomial or if it is Poisson. Okay, so in addition to learners' absence, also interesting in addressing shortage of teachers in rural schools. Previous studies have suggested that 1 in every 4 rural schools have shortages of teachers. Suppose 10 rural schools are selected independent of each other to check whether or not each school has a shortage. Which one of the following statements is incorrect? Okay, so whether or not, that basically tells me about it's a yes or a no. So that gives me the binomial. They tell us the sample is n is equal to 10. And see how everything is written out in numbers. So very difficult to pick that up. And when they say the shortage of teachers is 1 in 4. So the shortage of teachers is 1 in 4, which is 0.25. Okay, so they do give us the pi, but they give us in words, which again sometimes can be a bit more difficult to pick up. Okay, and now they ask us information around that. So if they want us to work out the probability, they would need to give us a x in the question set at the bottom as well, because they didn't tell us anything about that x in the question up here. Okay, so in a binomial experiment, each trial is independent of one another. That is correct. That is also out of the binomial distribution, and they told us here this one is independent. Okay, the probability that 5 of the 10 schools have a shortage. Okay, so here they tell us, so what's the probability that x is equal to 5? So that we will work out. The expected value of number of schools. Okay, so now we need to go back to the expected value, how we work that out for a binomial distribution. And the expected value is a simple calculation of, so let me just write it in here, then we have it as well for you. It's just n times, so let me just make sure that is how I had it last time still. Yes, n times the pi. Then the probability of a school having shortage of teachers. So that was the pi that we actually calculated. While that of a school not having a shortage. Okay, so that was the 1/4. then if it is the opposite, it is 1 minus the 0.25, which does give us that. So D is also right. And then the last one, we need to work out the probability that 4 of the okay, so the probability that 4. Okay, so before we go to the table to look at that, here's a one that I thought we can also just work out before we even need to go to the table. So we know n is 10. We know that pi is 0.25. So if we multiply that out, we need to get the expected value, and then your expected value is 2.5 and not 4. Okay, so 2.5 is the expected value, not 4, so that is wrong. So this would have been the incorrect one. But let's for this go to the table. So we go to where n is 10. Okay, so there n is 10. What I now also hate is that this one was split, so we just need to make sure. So I just now want to see if I can get back to I don't want a free trial. How can I just somewhere okay, no I can't. Okay, so if that is with 0.75, that would have been your 0.25. I just want to see where it is in 10. So again, much simpler when this is printed and we can work off the printed version. So if that is 10, so that is 0, 1, 2, 3, 4. So the probability of x equal to 4 is 0.1460, and the probability of 5 would have been x equal to 0.0584. So the probability of x equal to 4 is 0.1460, which is correct. And the probability of x equal to 5 is 0.0584, which is correct. Okay, but again, in the exam, you will have it printed. So hopefully, please try to, if you can, get it printed. It's just much easier to work with a printed version of the tables. Okay, so that was the Poisson that we looked at the expected value. We looked, binomial, where we looked at the expected value. We looked at how to work out the probability when they give you x equal to something, and also where we needed to work out the pi because of the near sentence that they've given us. Okay, so let's see. I think this is the last of the binomial, and then we go into the next set. So I just want to make it bigger. So let's first read this and see if it is, again. Now suppose 8 rural schools, so we're probably using the same information still, but they need to tell us. Now suppose 8 rural schools are selected independent from each other. Check whether or not each school has shortage of, okay, so again, independent, whether or not it has a shortage tells us it is binomial. Similar to the previous question, studies have suggested that 1 in every 4, so there again, pi is equal to 0.25. Which one of the following statements is incorrect? So very similar to the previous one. So that the next set is nearly, they will ask you it a bit differently. So we will need to, they're going to ask the at most, and a bit more of that would be included here. And then maybe the variance will also be included. So let's look at what is in here. So the probability that at most 1, at most 1, so probability small or equal to 1. Okay, the variance formula is basically the mean times 1 minus pi. Okay, so that will be the variance. Probability that at least, sure, there's a lot of these questions now in here, so they're testing nearly all of this in this one question. The probability that at least 0, so at least 0, the probability that at most again, the probability that at least, sure. Okay, so first one that I want to do is this one, because for variance calculation, then at least I don't need to go to the table yet. So from a previous question, that was 2.5. So if we multiply that by 0.75, because that is 1 minus 0.25, we get 2.5 times 0.05, 1.87. Did I now work this out correctly? It was 2.5. 2.5 times 0.75. Okay, this now is interesting. And I assume then this was out of one of your assignments. I assume there was a Arieta with this, because yeah, it's definitely two things. Okay, sorry. And that is how quickly one makes a mistake. The n is not 10 anymore, it is 8. Sure. Okay, that was very easy, that one could make the mistake. So it is actually n, which is 8 times 0.25 is 2, and 2 times 0.75 is 1.5. Very easily one could make, and now please in the exam also be careful when it is one question following up on the next one, because I just was lazy to work it out again and just assume it was 2.5. Then one could have easily made that mistake. Okay, so please, when you are in the exam, just make sure if it is a follow-up question, because even in this one they said similar to the previous question. So one is very easy to make that mistake that you then treat all of the information as similar to the previous one. Okay, so that one is correct. So then what I want to nearly look at is, we know that we deal with n is equal to 8. So when we look at the table, n equal to 8, basically we have from a 0 to a 8. So I first want to look at the 2 that looks at everything bigger than 0 and everything smaller than 8. So everything bigger than and including 0. So where was that 2 point? So we basically, with that, is looking at everything bigger than 0 and including 0 is all of them. All of them will be equal to 1. Okay, the same when we look at everything smaller or equal to 8 is all of them. So all of them will be equal to 1. Okay, so with this one then, we know that is incorrect because it's not 0, it should be 1. With this one, it is correct because it is 1. So before we get to the other two, this has shown me that option 3 or option C is the incorrect one. But let's first also go to the other two. So smaller or equal to 1, so that includes 1 and 0. So it is those two. So it is 0.2670 plus 0.1001. So that gives us 0.367. 367, and if I rounded my calculator off to 4 decimals, 3671. Okay, so that is correct. Then when I need to look at bigger or equal to 1, so bigger or equal to 1, just make it a bit smaller. So bigger or equal to 1 is all of them. Okay, so for me, I am not going to add all of them together. That is just not. But if it is bigger or equal to 1 and I needed to add all of them together, very simply just to say, instead of adding all of them together, to say 1 minus that, because then I do get all the ones in yellow. And we know the probability must be equal to 1. So 1 minus that 1 of 0.1001 will give me the rest in yellow. So then for that one, I can say 1 minus 0.1001. And let's see what that gives us. the 0,8999, which is correct. Okay, so again, in the exam, you could have added all of that together. It will give you the 0,8999, but much easier to say 1 minus that one individual one, and it will give you everything that was highlighted in yellow. Okay, so that is binomial distribution. So let's quickly, any questions on that before we continue to? Or is everybody fine that we can continue?
Yeah.
Okay. And hopefully it makes a bit more sense. But I do like this table, because the table it really assists us that, because I get confused with all of these at least and at most and in betweens. And so, yeah, so let's continue. I think let's copy this one just to one of the next. Okay, so not that one. Okay, so at least not there. So I'll just copy it to somewhere for next week as well. Okay. So the next one is to look at Poisson distribution. So within Poisson distribution, there is always a time. So and let's read through the question. So suppose further that the number of grade 8 absences are Poisson. Okay, so there they tell us it. With a mean of 3 learners. So we know that then the mean is equal to 3 learners per day. See, so there is your time that is included in Poisson. And that is nearly, so if I didn't tell us it's Poisson, the time is the giveaway in that. Okay, so use the formula. So we'll get to the formula. It is open book, so you don't need to remember the formula of a Poisson distribution. Please don't. And I'll distribute the formulas that the lecturer have shared again with you. And I'll also share, I must just go and find that again, the one that I've done some work on and explanations on as well. I'll share that also to somewhere in my notes. Okay, but use the formula to calculate the probability that 2 learners are absent on a random chosen day and choose the correct answer from, not form, from the list of options below. Okay, so let's just, I can't even remember what the formula looks like. So let me copy and paste it into this, because again, please don't, I have to check. Okay, so that is somewhere. Let's just, if someone gets it before me, just let me know. So it wasn't at the beginning of the chapter. There it is. Okay, that's a very ugly one, but let's now I'm let me just do it. While we are busy with that, it doesn't want me to do anything else unless I upgrade. Okay. Okay, so there we have it. So let's check it out. Okay. So what was also interesting for me in this one was that they actually had the formula for binomial also that they asked us in one of the previous questions. So let's look at this. So lambda we know is 3 to the power of x times e to the power of minus lambda, so minus 3. So minus 3, minus 3, minus 3, minus 3, minus 3. Okay, so that's all of them is still applicable. And so what this means is 2 factorial, so it's 2 times 1. So for this one, it doesn't matter, but if it was 3, it would have been 3 times 2 times 1. So just if it is something else, that is what it means. So for this one, it's not the issue because it will be 2 times 1. So at the top, there we have 3 to the power of 2, it's 9, divided by 2, which gives us 4.5. So 4.5 e to the power of minus 3. Okay. So this was basically, we looked at the Poisson distribution that it is in your textbook and in your study guide. And just straight from that, they ask us to substitute some of the numbers and work it out. Okay, so I think the only thing that was nearly the catch is what to do in that formula with the x factorial. Okay. Questions on this? I think this one is a bit more straightforward in terms of some of the other questions on Poisson distribution. So let's go into the rest of the more difficult ones. So in this one, let's see. Okay, so there again they tell us it's Poisson. So suppose the number of voters entering a voting station in the UK per minute is Poisson distributed with a mean of 2.5. Okay, the mean is 2.5. So we know the lambda is 2.5. And then they ask us, what's the probability that exactly, so x equal to 4, we will go to the table for that. The probability that no one will enter Okay, this is a weird one. So is no one equal to 0? Sure. Okay. If X is the number of voters entering, okay, so there's a variance that we need to calculate. There's a different probability and a different probability. Okay, so the first thing, nearly the mean and the variance of the Poisson distribution is exactly the same. Okay, so that is one of the rules, mean and variance exactly the same. So the variance of X, it is 2.5. Okay. Oh, actually we're looking for the correct one. So that was correct. Okay, so this was an interesting one. I thought we would work out the rest as well. So in the exam, I would always go to the things that I think it's the easiest to look at. So for Poisson distribution, mean and median always exactly the same. So it is 2.5. Okay, but let's look at lambda 2.5 on the table, and let's see what those values should have been. Okay, so let's go to the Poisson distribution. I think the tables for Poisson is much easier to work with. Don't want to skip it, so let's just make sure. Okay, binomial, Poisson, and we were at 2.5. Okay, so we were, let's just this time make sure, 2.5. Okay, so at 2.5, there was equal to 4, so it's 0,1336. Okay, so it should be 0,1336. I just want to check where did I get the... Okay, so if we looked at 3, we would have set the 0,21, but they told us it's 4, so that is why that one was wrong. X equal to 0. Let's look at X equal to 0. 0,0821. 0,0821 instead of that. So that is why those two are wrong. Okay, so let's look at how would we have done this one. If X is the number of voters entering a voting station in a given minute, then X smaller than 1 bigger or equal to 0. X smaller than 1, so we're not including 1, bigger than and equal to 0, so we're actually only looking at 0. Okay, so it would be the 0,0821 again. So basically looking at, and now you can also see the different way that they could have asked it. So excluding 1 but including 0, so it's only the 0. If X is the number of voters entering a voting station in a given minute, then X bigger than 0, X smaller than equal to 1. So this, we could have phrased that one the same to say, what is the probability of X equal to 1? Okay, so it includes 1, but it doesn't include 0. So that is the different way we could have done that. So X equal to 1, 0,2052. 0,2052. Okay, so this is then why that one is also wrong. But I just wanted to show you when you get it in this format, how to work it out. Okay, there's one more left for Poisson, and then we can go into the normal distribution part as well. Okay, so the last one, Poisson, and let's just look if it is, okay. So how it seems to me is that mostly for the Poisson, they would tell you in the exam it's Poisson, and then with binomial, they will tell you a bit less around it and more about it is for independent trials and things like that. Okay, so what else do they give us here? So suppose now that we have knowledge that the number of grade 10, so again that grade 10 questions, absences at one of the schools are Poisson distributed with a mean of 4.2 learners per day. So let's just 4.2. What is the probability that at most 10? Okay, so that one that I needed to copy in was actually perfect for the last question as well. Okay, so at most 10, so let's look at most. So what is the probability that x is smaller or equal to 10? Sure. Okay, so 4.2 and then smaller or equal to 10. 4.2 smaller or equal to 10. Okay, so unfortunately here, there's an option that we can, or we basically add all of them together to get your answer, or we say 1 minus the rest. Okay, so I would rather say 1 minus the rest, and let's hope that we then also get to the right answer. So 1 minus, what is it, 0.0027 plus 0.0009 plus 0.00, what is it, 3 zeros and a 3 plus 0.0001. Okay, so when I add all of that, I get 0.004. So I'm just hoping that there's no weird decimals. Okay, so luckily one of the options was not 0.004. That one doesn't quickly jump into that. So 1 minus that is equal to 0.996. Okay, and it gives me that option of option B, which is 0.996. Okay, again, one could have made the mistake that you see the 9s and the 6 and you want to say option A. So just be again careful in the exam when there's things that looks very similar that you just get your answer as well. So just be very careful for this one. Okay, so that was Poisson. So just a quick check-in before we continue. So any questions nearly on up until now, the discrete, the Poisson and the binomial that we did? Okay, so then we just continue with the next set of questions. So we're actually going nice and fast today. So let's move that one out and let's see. Okay, so now we go into study unit 6, the normal distribution. A normal distribution, they can ask you in a few different ways. So the normal distribution is, and we will cover a few now. So they can ask you a kind of definition question. They can ask you a lot of this. So this one, I think it's very important that we nearly go through every one to make sure we understand. And I'll draw graphs and things like that. And then they can ask you nearly, given some information, then what is the correct answer. Okay, so first the kind of definition question. So which one of the following statements is incorrect with regards to the normal probability distribution? The z-score of a mean of a normal distribution is 1. Okay, so for you guys, yes or no? And let's go to, I think it nearly in the Z table. So that question tells us if it's a normal distribution, Z is always equal to 1. So let's go to the table that way. So this is a normal distribution. That is z-score. So they tell us for that normal distribution, z is always 1. Okay, so that's incorrect because z can actually be any number from infinity to minus infinity to positive infinity, actually. So that one is incorrect. So luckily for me, if this was my exam, I would have stopped at option 1. But because the questions can be shifted which options, it might be that your option is only in the exam at the later stage. So let's look at all the options and see why they are actually in this instance correct. The smaller the value of a standard deviation, the narrower and steeper the curve. Okay, so that one is nearly to show. So if we have a normal distribution with a big standard deviation, it will look something like this. If we have it with a narrow and steep or a small, it will look something like this. So then it is the smaller the standard deviation, the narrower and steeper it is. The bigger the standard deviation, the longer that normal distribution becomes. Okay, so that is correct. So let's look at the next one. The mean of a normal distribution can be any numerical value, negative, 0, or positive, which is correct. Okay, so when you can have a negative or positive mean, you can have a 0, very seldom, but you can also have a 0. The area to the right of the mean of a standard normal distribution is 0.5. So in the middle, that part is 0.5, that part is 0.5, so that is correct. 95% of the values of a normal random variable are within 2 standard deviations of a mean. Okay, this one, it's nearly, if you look at, and that's the table that they actually share in what is it, in study unit 8. So they don't always say that in the study unit, but this is also, this they have taken just out of your study unit 6. There is in study unit 6, let's quickly go to it. There is a graph where they show that. They show, I think, one standard error, or 1, 2, and 3. So let's just quickly, just want to make 100% sure it is there. Otherwise, I get that for you, but I'm sure. Okay, so that was the 0.51 that they asked in option 4. Okay, so if it isn't here, I will copy something out of the textbook for you. Okay, so that was the one. Okay, so it doesn't seem like it is here. So I'll just okay, so there I just copy something out of the textbook for you. Okay, so let me just make a note on slide 38 just to get you that, and I'll just then copy it into that slide for you, because there is one with 1, 2, 3. Okay, I'll do that for you. Then that is also covered, that if I ask a standard deviation of 1, 2, and 3, and that's normally where it stops. So one standard deviation is normally 1 comma, or sorry, is 99, 2 is 95, and 3 is normally something like 64, 65%. But I'll get that for you, that it is covered for you if I ask anything else on that. Okay, any questions on this of the definition question, really? And they like to ask a definition question, and normally 1 or 2 questions. So if it is with your binomial Poisson, or if it's with normal distribution, or if it is with the chi-square, they like to ask between those ones, or even the first study unit of a sample and the population. Okay, so distribution question done. So let's go into actually working with the, unless there's a question. Jolene,
Yes.
question on your side.
No, I'm happy. Thank you, Jean.
Okay, cool. Okay, so for this, we need to have the Z table with us. So we can't do a question like this one without a Z table. The nice one here is that we sit with basically 2.8, 2.1, 0, 2.1. So luckily we sit here with the same numbers, that we can nearly reference the same numbers every time. But it can also be that you get 5 options with just different things to look at. So as we go along, I will include a question like that as well. But let's look at, we need to look at this, the standard normal distribution Z with one of the following which is incorrect. Okay, so one is incorrect. So again, this will be in the exam, there will be probably 3 or 4 randomized options that you will get in the exam. So my option A hopefully is the incorrect one, that I don't need to go through all of them, but it can be worse as well. So let's just check all of them. So they ask us, and I always want to draw the diagram. And in this instance, only there they start to ask us probability. So this one, and let me just, that it looks at least a normal distribution. So they ask us the probabilities that Z is bigger or equal to minus 2.8. So remember, Z in the middle is always 0. So let's say minus 2.8 is here, and it's bigger. So I want to know if that area is exactly the same as 1 minus the probability that there's the 0 again. So that was the bigger than 2.8, but 1 minus that is actually that area. Okay, so what do you guys say? Is those two equal to one another, or is it not? So is that area and that area exactly the same?
Yes.
Okay, correct. So again, with the basically the theory of the normal distribution, symmetrical, so that small area of minus 2.8 is the same size as that small area of 2.8, so then the opposite also applies. Okay, cool. So first one correct. Unfortunately, I'm looking for the incorrect one. Okay, so, and that's why I like to draw the diagrams, because that just makes it easier for myself. So the probability that Z is smaller than minus 2.1. Okay, so that is that equal to the probability that Z is bigger than 2.1. Okay, so now you can see there they ask the bigger area for us. Here they're asking is that and that the same size? Yes, it is. Okay, so nearly the same that we did up there. Here we can see that, yes, it is equal to one another. So again, using the symmetry of what's happening on one side is the same as the other side. Now we start needing to look at tables, unfortunately. So we didn't get away from working with tables. So minus 2.8 there's the 0. So minus 2.8, so Z smaller, bigger or equal to, so it's bigger or equal to, but smaller or equal to. So we're looking for for that value. Okay, so the easiest way for me to work with this is to basically look at the minus z table and see what that small area is. So let's do that, minus 2.8. So let's z minus 2.8 is 0,0028. So that small area is 0,00, was it 28? 26. Okay, 26, 0,0026. Okay, then what I also know is that this area is 0.5. Okay, and we saw it in the previous question as well, where z equal to 0, that side is 0.5, the other side is 0.5. So I can work this out, that green part, to say 0,5 minus 0,0026. That should give me the answer, and that is 0,4974. 4974, which is correct. Okay, so just following the principles again of the x or the z that is smaller than 2.8, we go to the negative table. In the negative table, we get the 0,0026. Then from there, we know that half of the probability under the normal distribution, half of it is 0.5. So if we then sit with that, we have it that 0.5 minus the 0,0026, that gives us the 0,4974. Okay, so let's look at the next one. Okay, so remember we now already know that is 0,4974. So now we need to just get that. So the next one, z bigger than minus 2.8. There's the 0, and smaller than 2.1. Okay, so we want that area. Okay, so now for me, the easiest, okay, so now here's two ways that you can do it. You can, or you can say that's the full one, and I subtract that small area, which is 0,0026, and then I need to subtract that small area. Okay, so to get that small area, I would have gone to the negative table again and looked at 2.1, and my 2.1 would have been 0,0178, 0,01. Why did I set 78, but I think it's 79, sorry. Okay, so then basically one can say it's 1 minus 0,0026 minus the 0,001. I'm reading too many numbers today. Okay, and let's see what that answer is. So that's for one way we can do it. Which gives us 0.9795. Okay, so that was for one way, we got the answer. The other way is to say, well, I use my positive table to get the 2.1 because that gives me that whole area. So positive 2.1 0.9821. 9821. And then all I need to subtract is that area because that is the one that I don't want included, which is the 0.0026. So if we say 0.9821 minus 0.0026, we also get that answer. Okay, so here we actually have two ways that we can work it out, and it's nearly to say what's the easiest for yourself. I personally would have gone this route to say up until 2.1, I get the value, I subtract that part, so and it gives me 0.9795. But you can also say everything underneath a normal distribution needs to add to 1. So if I have that small part, I subtract those two from 1, I will also get the same answer. Okay, so I just wanted to show both of these options, how to work it out. Then obviously if all of those are correct, this one is wrong, but let's just include a new slide so that we can just work that out. So they ask us to work out z smaller or equal to 2.1 bigger than 0. So they ask us to was it 2.21 or 2.1? Okay, so that is what they've asked us, between 0 and 2.1. Okay, so we need to work out that. So here we already know what is the 2.1, so 0.9821. So that 2.1 is 0.9821, but that includes that whole area. Okay, I only want from 0 to 2.1, so in that space there is a 0.5, so I then need to say that minus 0.5 will give me the answer I'm looking for. So it is 0.9821 minus 0.5, which gives us 0.4821. 4821, which was wrong. Okay, so we needed for 0.4821 and not 0.4221. Okay, but this is nearly how you will get in the exam as well, that they ask you the different sets in one, because here they test that you understand the positive and the negative table. Here they also do that that you can use both tables, and with these three, it is nearly to that you, with the one that you most comfortable with, that you work that out. So again, there is other ways to work it out. Like I showed in option D, there's 2 ways, but the other ones, there's also more ways that you can work it out. Okay, so are you guys, does this make a bit more sense than when we started off this way at the beginning of the year, or just want to get a check in that it nearly is better now and a bit simpler when you need to do it in the exam?
Yes, it is. Jean, sorry, can you please go through number 1 again? Because I think the 1 minus would confuse me.
Okay, so let me, I'll add a new slide as well that we, so basically probability that X is, I just want to get, why did this now? Take that away. Just want to, probability that X, let me just get the wording right. So let's, just do that. And we only focus on this one. Okay. Okay, so probability Z bigger or equal to minus 2.8. Okay, so let me first show that again on the graph. So in the middle is the 0. So somewhere here is minus 2.8. Okay, and they ask us for the bigger number. So they want us to work out that. So let's actually work it out. So the minus 2.8 was 0,0026. So that small area was 0,0026, which then tells me that, oh, let's just get a thicker. So this big part is actually 1 minus 0.0026, which is 0,9974. So let's use the actual numbers that, okay. Then they ask us on the other side, what is the probability of 1 minus the probability of Z bigger or equal to 2.8? Okay, so I want to know what is, okay, so this is 2.8. So what they're asking me here is 1 minus that part. So 1 minus that part is actually this component. So 1, we know under the normal distribution, everything needs to add to 1. If we then say, okay, well, that small part is the 2.8, I want 1 minus that. So I'm actually want to know what is the probability up until 2.8. So then I can go to the positive table of 2.8, and I see 0.9974. So, and look at how it's graphed, everything up until that 2.8. So everything up until that 2.8 is 0.9974, which is exactly the same as that part. So actually, by looking at the numbers, we also could have said that the two are similar, that we didn't need to go into the theory component. We could have actually worked out the numbers and gotten to that as well. Does that make a bit more? I think with the numbers behind it, I think it probably will make a bit more sense. Does it, Tembi?
Yes, it does. Thank you.
Okay,
Yes,
cool.
thanks.
Okay, and I think this is nearly how they're gonna ask it in the exam as well. Nearly between, because that where is it now? That first 2 questions, it's theory questions. Okay, so my internet is not good at the moment, so hopefully you guys can still hear me. So those first 2 options was theory, but you can also work it out with the numbers. So you would have seen, if we've done this with actual numbers, you could have gone to the minus 2.1, gotten the answer. Here we could have said 1 minus that bigger part if we used the positive, and we would have gotten the same answer. So we could have done it with a theory like I did, or we could have done it with the actual numbers, and you will get the same outcome. Okay, so
Okay.
cool. So the last one for today, and then we can nearly end with study unit 6, because study unit 7 is nearly just a continuation of study unit 6 with a bit more difficulty. So then next week we can fully go into study unit 7 and then continue with 8 as well. But let's quickly look at this one to finish it off. And again, table or graph. I can't do without my graph. So let's also read what they ask us. Given that Z is a standard normal distribution, what is the value of Z such that the area to the right of Z is 0.2061? Okay, so we know that is 0. So I'm looking for a Z where to the right of it, to the right of that Z value, the area is 0.2061. So if that is 0, to this side it's 2.5. So this whole area is 2.5. So let's say that is my Z, and that area is 0.2061. Okay. So I need to work out what is that Z. So you will see it is to that side, so my Z must be positive. Okay, that eliminates that one. eliminates that one. Okay, because my Z needs to be positive. Then when I look at the negative 0.58, I see there's a positive. When I look at that one, there's a positive. So I'm nearly, and again, this is just my feeling, it's that because they give us those two negatives, it's probably one of the two positives and not this odd one in here. But I might be wrong. But so then there's two ways of doing it. So the first option is to say, I can go to the negative Z table to get my answer, but my answer needs to be positive Z. So I just need to look for that value, but I need to remember when I write it down, it needs to be positive. Or the easiest way for me is to say, I need to get actually that area, work with a positive Z. So how big is that area? We know that everything underneath the normal distribution adds to 1. So 1 minus 0.2061 will give me what is underneath here, which is 0.7939. Okay, so I need to go to the positive Z, and in here, I need to go and look for a probability of 0.7939. 7939, actually on the spot. And that is 0.82, 0.82. Okay, which is that option. Okay, so that is the one way. I could have gone to the negative table and looked for the 0.2061. Negative table, because the negative gives me that small area, 0.2020. So that's not 2 yet. 2061. Okay, so 2061 would have given us the 0.82 as well. Okay, here now obviously it shows negative, but I'm working on this side of the table. So I always work on the positive side. So again, it gives me the 0.82. Okay, so I could have done it that way as well. So again, personally, I would have gone, make it easy for myself, I would have said 1 minus to get the 0.7939, go to the positive table, 0.7939, and read it off as 0.82. That is how I would have done it, but I don't now need to go to the negative table in the exam. It's very easy again, because you in the negative table, just to say minus 0.82 and not realizing you need to still turn it into a positive. So that is how I would have done it in the exam, is to make it as simple for me not to make mistakes. Okay, questions on this one?
Oh, no, Jean, it seems a bit clearer now.
Okay, cool. Okay, so next
Yes,
week
it does.
we will nearly continue with some of these. We'll add the proportion, We'll put in some of the standard errors for the 2 as well. But again, we're working with the Z table next week. So for next week in the Z table, the confidence intervals and the hypothesis, we will work with the Z tables. Okay, I'll put the video up in the next hour or so as well, so that it is available for you guys to go through it again. Okay. Any other questions? Questions on the exam or anything as you go through at the moment? And please pop a WhatsApp message as well. Not worried if you do that. We can add some of your questions into this pack. As you'll see, the pack is just growing, so that by that last week you will have the full pack that you can also just look at it with the notes in between. Then I'll also do the PDF for you of this, that you have that. Anything else?
Jean, I'm just concerned about the Excel. If we now go and we try and simplify with the Excel spreadsheet, and you get stuck, is it okay if you just go back and just put it on the group that just to clarify where we need help?
With the
Excel spreadsheet.
yes, with the preparation, no
Yes.
issue at all. Obviously not in the exam.
No, I'm talking about preparation.
Yes, please. That's why the group is there, and that's why I'm also pleased, because in the exam the Excel needs to work for you. So while you're practicing, please ask.
Because I'm just concerned on the time, because I'm looking, our assignments is 3 hours.
I know.
And the exam is 2 hours. I think I'm already getting anxiety when it comes to that.
The same on my side. So that is why I want you to use the tool. So please practice with the Excel, that it's not nearly only you use it in the exam, that you nearly use it now the whole time, and ask. Please ask, because that's the easiest for us to make sure that you save time with some of the other questions, because you can't work some of these things out. Where was like some of these things,
Yes.
It's just you want it's different if it is the Q1 and something that you need to work out, but the population and all of, we need to make it simple for you. So please, as you work through it, you're working in your Excel, something doesn't make sense, ask. There's no issue at all. And that's for nearly everybody that will listen to this during the next few days as well. It is, please, the Excel needs to assist you in the exam. So use it, study it, make your own notes on it. I'll see if I can in the next week actually combine all the sheets and post it on the WhatsApp group as well, that you only work in one workbook for the Excel as well. That will be my mission for the next week, just to add all of that together, and then I'll post it on WhatsApp, but I'll also share it on the other areas.
No, thanks, Jane.
Cool. Okay. Great, everyone. Have a good weekend, and yes, please, even over the weekend, bombard the WhatsApp group if you want to. No issue about that. Okay, let me just stop the recording, and then I'll have it available later today as well.